I already have my window open trying to cool it off in here. And the heater is off. It has been off all day.
We get extra credit.
Huh?
We get extra credit if we do that.
Every week.
For real?
You've
always
Yes.
done that?
Yes?
What?
No, it was just new this semester, but yeah, like that went up like the second week, and I talked about it briefly, and it'll be up all week, so like you don't gotta rush. There's no problem every week. Yeah. I know. No, it goes into homework, but for some of us that does push our homework above 100%, which can, like, it still pulls up, like, it still helps. So it's okay. Which IU is apparently cool with because my professor definitely is doing that with our discussion board posts. So. Ooh, it's up. Do you need me to zoom in on something? Surfing cat. Pencils, surfing cat. All right. So we kind of started talking about this one on Friday, being able to notice some things. We're gonna go the whole way through it. There we go. I don't know why I was in that mode. Oops, sorry. Fix. That's what it was. I just hit the wrong button. There we go. So I want to start over here. What quadrant is theta going to be in if it's between pi over 2 and pi? 2. It's in quadrant 2. So if we were to sketch out where theta is, all we know is that it's somewhere in quadrant 2. I don't have any details about it other than it's over here. So here's our theta. We also know that the cosine of this theta is negative 11 over 61. So cosine tells us what parts about this triangle? Yeah, it tells us our hypotenuse and our adjacent, right? So we know that the adjacent side is 11. Our hypotenuse is 61. And which piece gets the negative? The 11. So we got to make sure we keep track of that. How can I figure out what this other leg of our triangle is? Pythagorean theorem. Woohoo! So we're going to take our negative 11 squared plus something squared, and it equals 61 squared. So negative 11 squared is 121. Plus our b squared, which we don't know yet. 61 squared is not one we probably know off the top of our head. But we have calculators, and they're our lovely best friends. What is 61 squared? $3,721. So what is b squared going to equal? You jumped ahead a step. So what does b equal? Yeah, you're right. Yeah, you just jumped a step on me. So our b equals 60. So our sketch is really not to scale, but that doesn't matter anyway because it doesn't really matter. Because what we want to get is we want tangent of theta over 2. So we need to pick one of our tangent formulas to fill in. We have 3 choices. We have lots of information here. We can use absolutely any one of them that we want. Genuinely, it doesn't matter. So let's see. I'm just going to give them names just so we can talk about them. Which one do you want to use? A, B, or C? A. Boop. So what we're going to do is we're going to take this half angle formula and we're going to substitute in the values we know. So we're going to do tangent. Ooh, my screen's being a jerk over here. There we go. Of theta over 2. We know that's going to be plus or minus the square root of, oh, the bus is going to yell at us for a little bit. That is the one downside of the window. 1 minus cosine of theta. Well, we know cosine of theta. Negative 11 over 61. Over 1 plus cosine of theta. Negative 11 over 61. In quadrant 2, is our tangent going to be positive or negative? Because I don't really want to have to write plus or minus every time. Negative. Because in quadrant 1, sine and cosine are both positive, so tangent's positive. In quadrant 3, sine and cosine are both negative, so tangent's negative. Quadrant 2 and quadrant 4, tangent's going to be negative. It's been a minute since we talked about that. So I'm going to come down here, and I'm going to make these be less gross. So we know we're going to have negative square root. We had 1 minus negative 11 over 61. Which becomes 1 plus 11 over 61. What does that simplify down to? Hello. What is our numerator going to be? $72 over 61. Because we have to get to a common denominator, so it's going to be 61 plus 11. I left my coffee at my desk. How about our denominator? What's our denominator going to be? Similar vibe, common denominator. Let's simplify. What do you think, Tommy?
Negative.
No, that does not answer what I asked.
Oh, positive.
That still does not answer what I asked. I said, what's our denominator? Positive is not the answer. But it helps to listen. All right. Yes, it's going to be 50 over 61. Excellent job, ladies. Excellent job. Okay. So we have 72 over 61 over 50 over 61. What's going to happen here? The 61s cancel out. Guys, too many off-topic conversations. Ooh. So our 61s cancel out. Thank you. Awesome. Sadie. You get to go for your senior check-in. All right. So now we have the negative square root of 72 over 50. Can we simplify this? Yeah, what do 72 and 50 have in common? What can we simplify this down to? 36 over 25. So if I have the square root of 36 over 25, can I simplify that again? Yep, don't forget, this is negative 6 over 5. So the exact value for tangent of theta over 2 is negative 6 over 5. Everyone okay? Okay, cool. All right, we're going to do another one. Very similar vibe. Very similar vibe. So now we're given cosine of 2/3. Or cosine of x is 2/3. We know that 0 is less than x, which is less than pi over 2. And we want to find sine of x over 2. First things first, what quadrant are we in? 1. This tells me we're in quadrant 1. Which means, are our values going to be positive or negative? Everybody's positive in quadrant 1. All are going to be positive. So we don't have to worry about plus or minus. Everything's going to be positive. So if we're looking for the sine of x over 2, and I know my cosine, we can just go straight to our formula here. We don't have to draw our triangle. If you want to draw yourself a little sketchy sketch, totally fine, but you don't have to. We're just going to go straight to our formula. Sine of x over 2 is, we know it's positive, so don't have to put my plus or minus. We're just going to put our square root of 1 minus our cosine. We know our cosine is 2/3 over 2. So we're just substituting our value in. We know cosine of x. We were told the cosine of x. So what we have to do here is simplify. So what's our numerator going to be when we simplify? If I have 1 minus 2/3. 1/3. If we have 1/3 divided by 2, what do we have? 1/6. Close. Don't just turn it into a 6. This is the same thing as the square root of 1 over the square root of 6, which is the same thing as 1 over the square root of 6, right? But do we get to keep radicals in the denominator? No. We have to rationalize, so what do we need to do? Multiply by square root of 6 over square root of 6. We've got to have our denominator rational. So our answer is going to be the square root of 6 over 6. So make sure, if you just have a single radical, that we rationalize. If we wind up with a square root of a square root, don't worry about that. That's doing too much. But if we just have a single radical, we're going to rationalize. Sometimes we are going to wind up with, I'm just going to put in a little example to the side. If we had something like, oop, that's not a pen. Sorry. Square root of 1 minus square root of 2 over square root of 1 plus square root of 2. That kind of stuff we don't rationalize. That's square roots of square roots. That's doing too much. Even I think that's doing too much. Okay, so These kinds of ones you don't need to rationalize. If it's just a single square root, we're going to rationalize it. Okay? We're not going to have tons of these, but we will have them show up, particularly in the tangent style ones. But I just want to be clear. So if you got two radicals or radicals of radicals, you don't have to rationalize. But if it's just one, you do. Just because we could do it, it just takes forever. And I'm just giving us clear guidelines of rules as to when we do and when we don't. Trying to keep things clear. All right. So we're going to do another one like this. Very similar vibe. Before we get into the next kind of style of problem. So here we have cosecant of theta is -5/3. And we know that theta is between -90 and 0. And we're asked to find cosine of theta/2. This is one that the book loves to do because they are on purpose trying to trick you. Because what quadrant are we in? 4. They just listed it out all weird. We're in quadrant 4. So I'm going to give us our little sketch because what we have is cosecant. Cosecant also is known as our inverse of sine. So we know we have our angle somewhere over here in quadrant 4. That's a trash line. I'm going to do that again. There we go. No, that one's good. So this is our theta. We know that 1 over sine of theta is -5/3. So if we think about that as a reciprocal, because sometimes remembering which one's opposite, hypotenuse, adjacent, that kind of stuff is really hard with the cofunctions. So we can flip it. Sine of theta is -3/5. If we know that 1 over sine of theta is 5/3, sine is 3/5. So what pieces does that tell us? Opposite hypotenuse. So my opposite is 3. My hypotenuse is 5. So the other one's going to be 4 because it's a special triangle. And we got to remember, since it's quadrant 4, my x is positive, my y is negative. So it's -3. I don't know why it's on the opposite side of my line. There we go. So when we're going to find cosine of our half angle, we need to know cosine of the whole angle. So what is our cosine of theta? Mm-hmm. 4/5. So the whole sketching it out part is so that we can find the piece we need to plug into our formula. So I know the cosine of theta is 4/5. So when I'm trying to find cosine of the half angle, we can substitute that in. So we're going to have cosine of theta/2. Is it going to be positive or negative? In quadrant 4, are my cosines positive or negative? Positive. So we know it's going to be positive. Square root of the fraction 1 plus the cosine of our whole angle, 4/5/2. So when we come through to simplify, what's our numerator going to be? What's 1 plus 4/5? 9/5. What's 9/5 divided by 2? 9/10. And do we need to rationalize this one? Yeah. We have square root of 10 in the denominator. This is the same thing. I'm going to give us a little bit more space, which means I'm going to change the view. I promise I'll make it so we can see. Oh, helps if I don't hold the page. There we go. There we go. Because this is the same thing as the square root of 9 over the square root of 10. Square root of 9, that we know, is 3. So when we rationalize this, what is it going to be? Gorgeous. Perfection. That's exactly what it's going to be. So our cosine of theta over 2 is 3 square root of 10 over 10. Okay? So this is the kind of problem they give us a lot. It is not the only kind of problem on the homework, though. So let's go look at some of those other kinds. So we're solving, finding solutions on the interval, where we have one of our half angles inside of what we're solving. Ew. Mm-hmm. And I'll talk about that at the end. So what we have is we have sine of our half angle plus cosine of the whole angle minus 1. Well, we know that sine of the half angle we can write as this formula over here. So that's exactly what we're going to do. I'm going to replace, I'm going to change this back to the full thing. I'm going to replace this piece with our whole formula for the half angle. We're going to substitute it in. So we're going to put our plus or minus the square root of 1 minus the cosine of x over 2. And everything else is going to come down. Plus cosine of x minus 1 equals 0. So now I have everything into just cosines. Only thing up here is cosine of x. So our goal now is to try and figure out what cosine of x is. But we have that square root, and it's super gross. So I would really like to be able to square both sides and get rid of that square root, right? But that means I need to isolate my square root first. So what can I do to isolate my square root? Yes, we're going to subtract cosine of x and add 1. Minus cosine of x plus 1. So we're going to have right now plus or minus the square root of 1 minus the cosine of x over 2 equals 1 minus the cosine of x. Getting that radical isolated so that we can square both sides. Because we need to get rid of that radical, because that's super gross. So we're going to come through here and we are going to square both sides. Make sure that you are squaring both sides, not distributing a square, squaring properly. When we square both sides, this whole set cancels out, and we're left with our 1 minus cosine x over 2 equals 1 minus cosine square, or 1 minus cosine x, when we square that, is going to be what? It is not 1 plus cosine squared of x. What piece did we forget? The middle. It is not distribution. Think of it as a box. It's a box multiplier or a FOIL. Yes, dear?
Is it 1 minus 2 cosine x plus cosine squared of x?
Perfection. Excellent job, Connell. Oh, my foot just totally fell asleep. Oh my gosh, there we go. Stop. Oh my gosh. Go away. All right, so if you need to, box it out or write it out. Draw your arrows, bless you. Distribute it, whatever we need to do, but we're going to multiply it out. Now I have a cosine and a cosine squared. Whenever I see a linear and a squared term, what are we going to aim to do? Set it equal to 0 because we're going to need to factor. So our first step is to multiply absolutely everybody by 2 so that we can get this out of a fraction. I'm going to give us a little bit more space, which means y'all are going to have to follow my brain. Sorry. Zooming out. There we go. So we're going to have our 1 minus cosine of x equals 2 minus 4 cosine of x plus 2 cosine squared of x, because we multiplied everybody by 2 to get rid of that denominator. Then we need to set it equal to 0 because we saw we have a squared term and a linear term here. So I'm going to subtract 1 from both sides, and I'm going to add cosine of x to both sides. So now we have our 0 equals, and you can leave it like this where we have our constant in the front and our squared term in the back, or you can flip them around so it's a more familiar shape. I'm going to switch it just so that we can see it. Our 2 cosine squared x minus 3 cosine of x plus 1. And then, like we said, we're going to try and factor this. If it helps, if we struggle with factoring when it's got these trig terms in here, do a substitution. Do a u substitution for cosine of x and make this 2u squared minus 3u plus 1. For a lot of us, that's going to be easier to factor than cosine squared. And then whether you box, split the middle, factor by grouping, whatever method you choose, get that sucker in factored form. There are a lot of different ways to factor. I don't care how you factor, just that you factor. I drew the box in my notes, so there's no shame in the box game. No shame in using the box. If we are familiar with it, use it. If you are familiar with other methods, use it. However you factor, I don't care. Just factor it. When we get this into factored form, what do we get? 2u minus 1 and u plus 1, which then we switch it back into cosines. So we have 2 cosine of x minus 1 and cosine of x plus 1. So when we're looking for our solutions, look at each piece. So we have 2 cosine of x minus 1 equals 0, and we're going to do cosine of x plus 1 equals 0, just like we used to for quadratics. What's up? Yeah. solve those. Figure out what cosine's gonna be. Listen, I'm coming. What's up? I've got it from yours now. Okay. Yeah. Did I write it down? Should it be minus one? Yeah, should be minus one. Boop. And there too. Yeah, those should be minus ones. Call me out on it, y'all. I even have it as minus one on the paper. I just wrote it wrong up there. They should both be minus ones. Okay. So on our pink one, what is our cosine equal? Positive 1/2. So what are our x values? Pi over 3 and 5 pi over 3. How about for this purple one? Cosine is cosine of x is 1, which means x is 0. And since we were solving, way back up at the top here, it said solve on the interval, we don't need to put the 2 pi in. We're just solving in the unit circle, so it's just that first time around. Not including 2 pi. 2 pi is not included, so make sure when we're solving on the interval, we don't put 2 pi as an answer, because 2 pi is not included. It's excluded. So some of the questions we have in this section are going to be solving. Some of the questions we have in this section are going to be verifying. So we're going to go do one of those next. Boop. It'll say something like this, verify. And this section includes both our double and half angles. So I know I still have all of our half angle formulas on the side, but this section includes all the double angles as well. So it might not be that we need a half angle, it could be that we need a double. So we're gonna do this as a verifying problem. These aren't super long. We're gonna do 2 of them and we're gonna have time. Okay. Because what we're asked to do is we're asked to verify that sine of 10x is 2 times sine of 5x cosine of 5x. And I know when we're verifying, we pick one side and we simplify it as far as we can. And our instinct is going to tell us to do that right-hand side because there's more stuff going on. However, if we think about this as a multiple angle, I want to think about my left-hand side here. Because I can think about this in terms of a double angle. If I take this and rewrite it as, oops, sorry, you're having to follow my brain again. There we go. As sine of 5x plus 5x, and we make this an addition problem, or 2 times 5x. That's going to make it so that we can take this and put it in terms of sine and cosine. So you can either go all the way back to the addition or you can do the double angle. Either way is fine. The addition, probably good for us to remember. Sine is the one that takes our sampler. It takes a little bit of everybody. So sine is going to be sine of the first angle, 5x, times cosine of the second angle, 5x. It uses the same sign as our operation here. And then it's cosine of the first angle, 5x, sine of the second angle, sine of 5x. So do we see what's happening here? We have sine 5x, cosine 5x, and cosine 5x, sine 5x. Are these two terms the same? Yeah, because it doesn't matter what order we multiply it in. If it helps, you can always rewrite it. Sines first, sine of 5x, cosine 5x, plus sine 5x, cosine 5x. I just rewrote it switching these two so that they match up properly, because it doesn't matter what order we write it in. Is that the piece you're asking about?
Yeah, no, like,
Oh, the sum formula.
for the double.
Or you can go back and catch our double angle formula, which I just want to make sure I don't do wrong. That's addition. Okay, so I used the sum. You could also use the double angle, which would be sine of 2 times 5x, which would be 2 sine of 5x. Like, that would be faster, but I wanted us to remember. What the heck happened? There we go. Took me to a random Google page. So you can either set it up this way, or you can set it up as a sum, and I wanted us to remember our sum formula. Because this is sine of 5x cosine 5x. This is sine of 5x cosine 5x. So we have 2 sines of 5x cosine of 5x, which is exactly what we wanted it to be. That's exactly what we were trying to get it to match up here. So that's all it takes to verify it. We got our left-hand side to match our right-hand side. And you can either use the double angle, or you can use the sum of two angles. Either way is fine. You'll come up with the same exact answer, because they're all built off each other, which is what we did Thursday and Friday. We built them off of each other on how they lead into each other. So I'm going to do another one like this, another verifying one, so that we can see it. And this is the last one of the day and of the section. Again, we're given something to verify. We have cosine squared 3 theta minus sine squared 3 theta. And we want to know if that equals cosine of 6 theta. Again, I'm going to take the one that feels counterintuitive. I'm going to take this side because it has a bigger angle that I can put into these two pieces. You can either write it as the cosine, why is my pen being a jerk? There we go, of 3 theta plus 3 theta and do it as a sum. Or, you can do it as a double angle and do cosine of 2 times 3 theta. Either way is fine. It genuinely does not matter. These are two options to go through it. Same route, same highway, just a slightly different path. Okay? Either way, you don't have to do both. Just since that was something we spotted on the last one, I was just writing it out both ways. My instinct would be go the addition, because we've worked with that a little bit longer. But if you like the doubles, go for the doubles. So on the addition formula, cosine stays with his own buddies. So we know that's going to be cosine of 3 theta, our first one. Cosine of 3 theta, the second one. Cosine uses the opposite sign. And then we're going to have our sine of the first angle, sine of the second angle. So this is using our sum formula. And we can then simplify it. We have cosine squared of 3 theta minus sine squared of 3 theta. And that's exactly what we needed it to equal. The cosine double angle formula is very, very similar. Since we want sines and cosines, we would take our very first double sine or double cosine, and we would wind up straight at our cosine squared of 3 theta minus sine squared of 3 theta. So either way, if you do the double or if you do the sum, it verifies. And I don't care which one you use. It verifies either way. Okay, so that is the end of section 7.4. Just say I'm leaving this up for another hot second. Like I saw. Okay. All right, all the pens and cameras went down. There is a review for the quiz. And we're going to have time tomorrow to work on it. The review, it's in the little tray above the turn-in bin, so if you want to have it today and start working on it, you can absolutely grab it. If you want to wait and pick it up tomorrow, that's totally fine. What's up? Yes. This one? Got you. Okay, so we'll have tomorrow to work on it. So make sure you're getting out of the DC Precal bin, which is, I think, the leftist. It's a small packet. There's a page for the sums. There's a page for double angles. There's a page for half angles. So it feels like a lot, but it's split up into those 3 categories. So we can practice our sum and difference formulas. We can practice our double angles. We can practice our half angles. Extra credit. Cookie was only because my mom made cookies because it was her birthday. Because she had a real birthday.